This is example 6 from the PowerPoint, and it says concentrated phosphoric acid has a weight percent of 86% and a density of 1.71 grams per milliliter. What is the molarity? So weight percent and molarity are both measures of concentration. So here we're being asked to convert from one measure of concentration to another. The easiest way to do that is to assume a certain amount of volume. And it doesn't really matter what amount of volume you want to assume, but I'm going to assume 1 liter, okay? That's just the easiest thing I think to do, because I'm going to assume we have 1 liter of this solution. That way, when we find out the number of moles, to get to molarity, it'll just be moles divided by 1 liter, right? So let's just assume for a second we have 1 liter. If we have 1 liter of this phosphoric acid, how many grams of solution do we have? Okay? If we have 1 liter in volume of phosphoric acid, that means we have 1,000 milliliters of solution, right? 1,000 milliliters of solution. And we're given a density. The density is 1.7 grams per milliliter. And I like to use my density as conversion factors. So what this density tells us is that 1 milliliter of solution has a mass of 1.71 grams. Right? So we can use this to find out what the mass would be of our 1,000 milliliters of solution. So what this tells us is that 1,000 milliliters of solution has a mass of 1,710 grams, right? So that's how many grams of solution we have. Now, mass percent or weight percent is mass of the solute over mass of solution times 100%, right? So we're given that the mass percent or weight percent for this phosphoric acid is 86%, and we don't know the mass of the solution, of the solute, but we do know that the mass of the solution, of that 1 liter of solution, is 1,710 grams, right? So we can rearrange this, basically divide both sides by 100, so you get 0.86, and then multiply the 0.86 by the 1710 grams. All right, 0.86 times 1710 grams. And what that gives us is 1,470 grams, and that's grams of solute, okay? So remember, molarity is moles divided by liters. Because I assumed 1 liter, we already know the liters of solution. What we need to calculate molarity is moles of solute. Here I've got grams of solute, so it's a pretty easy calculation to get to moles, all right? Phosphoric acid looks like this, right? H3PO4. It has a molar mass of 98 grams per mole. So if we have 1,470 grams of solute, that's phosphoric acid, we know for every 1 mole, it would be 98 grams. So what we have is 15 moles of phosphoric acid. All right, and 15 moles of phosphoric acid is great. We're trying to get molarity. Molarity is just moles divided by liters. We said that we started off by assuming that we had 1 liter of solution. So this 15 moles must be in 1 liter of solution. So our molarity is 15 molar. And I've rounded this to 2 sig figs because our 86% had only 2 sig figs.